Hey everybody, this is Mr. Schultz here with you, and we're going to take a look at lesson 10.2.1, how can I solve the system? So this is going to be going back to equal values method, so there'll be lots of solving equations here, doing a lot of algebra. Make sure that this is a great lesson to find out how confident you are with doing some of your algebra. So let's take a look and remind ourselves what the equal value method is, and then we'll go from there. All right, so 10-40 says this: a set of two or more equations with the same variables is called a system of equations. When you see a set of two expressions that are equal to the same variable equal to each other, like you did in the previous lesson, you're using the equal values method of solving them. So you're basically just going to take two equations and set them equal to each other. So in our problem here, this is our situation. It says this. So this starts our problem right down here. It is time to cool off on a hot summer day. Team Sunshine is filling an inflatable kiddie pool from a garden hose. The pool has 30 gallons in it, and Team Sunshine is adding 8 gallons per minute with the garden hose. Next door, Team Breeze's pool is already filled with 180 gallons of water, and they are emptying the pool at 5 gallons per minute with buckets. Write two equations to represent the situation, and then use those equations to find out how long until both pools have the same amount of water, and check your calculations. So let's figure this out here. So let's take a look at what's happening. So first I've got Team Sunshine, and they're filling the inflatable pool with the garden hose, and it has 30 gallons in it, and they're adding 8 gallons per minute. So if I think about Team Sunshine, my key information is this. Their pool has 30 gallons in it. So whether it's been 10 minutes, whether it's been 0 minutes, it's starting with 30 gallons. But they're adding 8 gallons per minute. So I'm trying to find out what is my total amount of water in it, which I'm going to call that Y. And that's going to be when after how many minutes? Well, it's adding 8 gallons per minute. So 8x. So 8 times by the number of minutes, where x is the number of minutes. Because then if they've been filling it for 3 minutes, that'd be 3 times by 8. That'd be 24 gallons that they've added. They've been filling it for 4 minutes. 8 times by 4 would be 32 gallons. So that's 8x. But it started with 30 gallons. So I just have to add this 30 here. So this is Team Sunshine. So they've got 8 gallons per minute at 30 minutes. Let's look at Team Breeze. Do them in blue. Team Breeze next door is starting with 180 gallons, but they are emptying the pool at 5 gallons per minute. Well, if I'm trying to find out that total water, but they're starting with that 180, so just like Team Breeze, where they're starting with 30, they're starting with 180, but they're emptying or losing water at 5 gallons per minute. Again, X is in minutes. So now they've got our two equations. We've done that. We now have to solve them. So when we've been doing equal values method, we've been saying, hey, both these are equal to Y. So since they're equal to the same thing, I just take this expression and set it equal to this expression. So I just go and I say 8x plus 30, and that should be equal to y. Well, y is also equal to negative 5x plus 180. So I'm just going to set those two things equal to each other. Let me write that the same way that I wrote it the first time. So negative 5x plus 180. I'm just setting the two expressions equal to each other. And the whole point of doing this is, look at this, I have one variable now. I just have x and x. I do not have y. So I've eliminated one of my variables. So with that now, here's where our algebra skills are really going to start to come in handy. This should look like a pretty typical 8th grade problem here. So I can just add 5x to both sides to try to get rid of my x's and get them onto one side. So I'll be left with 180 on the left side. I'd be left with 13x and my positive 30, because I've got 8x plus 5x is equal to 13x. Remember, you're always doing the opposite of what you see. So since this is a negative 5, I'm going to add 5. Now this is back down to our kind of 7th grade level here. And you might even be able to just guess and check this and kind of find it. But let's do the algebra approaches because it tends to be faster. So I'm going to do the same thing here. I'm going to take the opposite of what I see. So I see a positive sign. So I'm going to do the inverse operation. So I'm going to take away 30 from both sides. You're left with 150 and 13x, and then positive 30 and negative 30 drop down to 0. Just like this one dropped down to 0. Now again, inverse operation. So multiplying 13 by x, so I need to do the opposite of multiplying, which is dividing. So I'm going to divide by 13 on both sides, and I'll end up with a crazy decimal. If I just put this in my calculator, I end up with about 11.538. So let's just call that roughly about 11.5 minutes, or about 11 and a half minutes is what x is equal to. So, and then if I was to check this, I just want to plug this into my equation and see if it makes the same number. So I'll plug in 11.5 for each of this. Now, because I rounded, it's probably not going to be exactly on. But here, I would just, in my calculator, I would just type this in. I'd say 8 times by my x, which is 11.5. Then I'd add 30 to it. It's a crazy looking 3. Let's try that again. 30. And then I do the same thing down below. I've got -5, but I'm going to multiply that by that same 11.5 minutes. And then, of course, it's starting with that same 180 gallons. And I just have to see if those two numbers are the same. So when I do this, the two numbers I come out with is 122 and 122.5. So they're slightly different, but remember that I'm rounding this number here. So since I'm rounding it, these numbers will be pretty close, but they probably won't be exactly dead on. So it is close enough there to know that this is my correct answer. So using equal values method can take a little bit of time here to do, but it is a very effective thing here of just saying, hey, I'm going to take both these two equations and set them equal, and then just do basic algebra and solve it. Let's see another example here. So on 10-41, the tortoise and the hare. The tortoise and the hare are having a race. In this tale, the tortoise moves at 50 feet per hour, while the hare moves at 250 feet per hour. The tortoise takes 8 hours longer than the hare to finish. What is the distance of the race? This is so little information, it seems kind of crazy. So let's see what we can do with it. Let t represent the unknown time in hours it took the hare to complete the race. Write an expression, not an equation, representing the time it took the tortoise to finish the race. So let's take our key information out of the question here. So the tortoise moves at 50 feet per hour, and the hare moves at 250 feet per hour. The tortoise takes 8 hours longer than the hare to finish. Well, to write the expression here, the hare, it took some amount of time. So this is the total time it took the hare to finish, is t. But the tortoise took the total time it took the hare plus 8 hours to be able to finish the race. So this is the amount of time that the tortoise took. So this would be t plus 8 would be the solution for the expression of how long it took the tortoise. Now in part B it says write two equations that represent the race, one for the hare and one for the tortoise. So if the hare took t amount of time and is traveling 250 feet per hour, then that total distance would be equal to 250 feet times by the number of hours, which we said was t. So this is for the hare. Now let's do one for the tortoise. Let's do it in green. I'm just going to shorten it to tort. The tortoise total distance should be the same as the hare, but it took 50 feet per hour times by the total time. Well, the total time was the time of the hare plus 8 hours. So there's our distance for the tortoise. So look at this. We can do equal value method. Again, now we've done these first two. It says what is the total distance? So I just need to take what was the hare's time, and that distance should be equal to the same distance that the tortoise went. But the tortoise just did it slower and with more hours. So now I'm just going to go ahead and solve this using equal value method. This is a distributive property, so I need to distribute this across. So 50t plus 400. If you don't know how to do that, just use a calculator. No big deal. Should be equal to 250t. So then again, I'm just going to solve this for x here, and I'm going to say that I'm going to take off my 50t. You could actually take off this 250t, but I like to take the smaller t because it helps my numbers stay positive. And I like to deal in positive numbers. Got 200t should be equal to 400 for the race. So then I'm going to divide by 200, and my t should be equal to 2. Now, this may feel like the end of the problem, but the problem says, what is the distance? Well, remember, t is representing the time it took the hare. So it took the hare 2 hours to run the race. So this is not 2. The distance of the race is not 2, because that would be a really short race and the hare would win really fast. So it took the hare 2 hours. So I can just take this 2 hours and plug that in for the hare and find out how long did it actually take. So if the hare went 250 feet per hour times by that 2 hours, well, that would tell me that the total distance was equal to 500 feet. So 500 feet is the total distance. Okay, so that's our quick review here of solving using equal values method. Let's take a look at the next one. And the next one, we might have to do a little bit of setting up the equation so that we can use this method here of equal values method. So let's see what that looks like. All right, so the two previous things here, we were set up and they both had these things that were equal to each other. But now I've only got one that's set up as y equals, and this one's set up as just x minus 2y is equal to 4. I don't have two things that are set up equal. So for equal values method to work, I first have to make the two things equal to the same variable. So I could go and I could set up this one equal to x and set up this one equal to x, or I could just leave this one alone because it's already equal to y. And let's try to get this first equation to be equal to y. Now this is going to feel a little weird at first because it's like, Mr. Schultz, what are we actually doing here? We're trying to get this y value by itself so that we can set it equal to this one. So just like before, if I'm moving numbers around, I can move variables around. So I'm going to try to get rid of this x because I'm trying to get the y by itself. I'm trying to get this thing by itself here. So I'm going to take off x from both sides. Well, I don't know what 4 minus x is, so let's just call it negative x plus 4, because 4 is positive and x is negative. This one here ends up being down to a 0. Then I've got this subtracting 2y is left over. Remember, I'm still trying to get this y here by itself. So I've got this negative 2 that's hanging out next to it, so let's get rid of that. So I'm going to divide by 2. But remember that you have to divide both of your other pieces on the other side by 2, not just one of them, because the whole thing makes up this whole side. I'm dividing this whole side by negative 2 and this whole side by negative 2. So in this case, y is going to be equal to, I've got a negative x over 2, or over a negative 2. That'd just be a x over 2. I've got a positive 4 divided by negative 2. Well, that's just going to be a subtracting 2. I've now just gone and rewritten this first equation in y equals. Now that I've got them both set up as y equals, now I can go through and do equal values method for both of these two equations right down here. So I'm going to just do a squiggly line here and get this set up. So I'm going to take this expression, negative 1/2 x plus 4, and I'm going to set that equal to my other expression, 1/2 or x over 2 minus 2. So now I just need to go and start doing some moving around here and solve for x. So I'm going to start with the smaller one, so I'm going to add 1/2 x. So when I add 1/2 x to a current 1/2 x, well, that's just going to be equal to a grand total of 1x. This stuff here is all going to go away. So and I'm just left with 4 and my subtracting 2. Well, that's pretty easy to see there, that I just need to add 2 to both sides and say that x will be equal to 6. Now, just like in our last problem with the tortoise and the hare, this is just telling me one of the solutions. It's just telling me what x is, but I don't actually know what y is. I don't know where these two lines are crossing. I just know one of those 2 points. So I just know that in my ordered pair, I've got the 6, but I don't know what the y value is. So to find the y value, well, I've already got the x value. I just need to take this x value and plug it back in and solve for y. So remember, my equation for solving for y was equal to negative 1/2 x. Well, x in this case is 6 plus 4. And that whole thing you could just put into your calculator if you wanted to, but let's see it worked out. So negative 1/2 times by 6, that'd just be negative 3. Then I'm going to add 4. So negative 3 add 4, y is going to be equal to positive 1. So my solution here should be 6, 1. So out of all this work, the only step that's new is this stuff here. This is just equal values method. This is solving for the other point of equal values method. This is our new step. If we have expressions that are not set up in the way that they should look, you just need to set them up so that both of them are equal to the same variable. Let's see one more of these, and I'm not going to do the whole thing. I'm just going to show you how to solve for the different variables. So here, I've got two expressions. I just need to solve for one of the two variables. It's very common to solve for y, but you can also solve for x. But let's just solve for y because that's kind of the way we're used to seeing it. So if I've got x plus 2y is equal to 14, I just need to, again, solve this one for my y value. Put that in blue there. So I first need to get rid of the x. So I'm going to take off x on both sides. We're left with 2y is equal to that negative x plus 14. So then just like the last one, I'm going to divide by 2y. Make sure I do it to both pieces. Y is going to be equal to negative x over 2 plus 7. I've set up my first one in y equals. Now I just need to do the second equation, so we'll do that right over here. Negative x plus 3y is equal to 26. So just like our last one, why don't you take a second here, pause the video, use this as your template to try to set this up in a y equals. I'll come back in just a second. All right, here's your solution. So I just took off the x by adding it because I need to get this down to a 0. So when I have a negative x and a positive x, that makes 0. So then I just move that down because I can't combine the x and the 26, so I just leave that. I'm left with this 3y. Well, I need to get y by itself again. Remember, I'm trying to get this variable by itself. So I'm going to divide by 3 to both these pieces, and they both make these fractions because 26 doesn't go evenly into 3. So you can just leave it as that. If you wanted to put that into the actual decimal form, I just don't really love the decimal form because you have to round it off. But the decimal form here would be 8.6 repeating x over 3 and y. So now you've got both of your equations, and you just need to do your normal equal values method. Set this expression equal to this expression, go through and solve it. It's going to be a little bit annoying because it's got fractions to it, but you can totally do it. So, in summary, equal values method is you want to write both of them in the y equals form. You could write them both set equal to x as well. Doesn't matter. But we're more used to y equals. So you just take your two equations, and you might have to set up this one so that it's in y equals. So here we are doing that, subtracting that 2x and moving it on to the other side. Now I've got both the equations in y equals, so I can set them up. Negative 2x plus 5, set that equal to x plus or x minus 1. It looks like it's missing this minus sign here for some reason. And then just go through and solve that, and then go back through and check it out. Plug it in and see if the point works. That's everything that I've got for you today. Have a good rest of your day.